Hi, everyone. Welcome and good evening. My name is Lauren Artilles, and on behalf of Harvard Bookstore, the Harvard University Division of Science, and the Harvard Library, I'm honored to introduce this virtual event with Robert J. Lefkowitz and Randy Hall, presenting their new co-authored book, A Funny Thing Happened on the Way to Stockholm, The Adrenaline-Fueled Adventures of an Accidental Scientist, moderated by Thomas Michel. I hope you're all well and safe on this snowy day in the Northeast. Thank you so much for joining us virtually. Tonight's event is the latest installment in our Harvard Science Book Talk series, which works to bring the authors of recently published science literature to our Cambridge community and beyond. Our spring schedule is packed with exciting talks. Coming up next in the series, this Thursday, February 4th at 5 p.m., we'll host mathematician and comedian Matt Parker for his book Humble Pie, When Math Goes Wrong in the Real World. To learn more about this and our other upcoming virtual events, you can visit harvard.com and sign up for our email newsletter, or check out the page harvard.com/science for more info. We also have a Science Research Public Lectures YouTube channel where you can view previous talks that you might have missed. This evening's discussion will conclude with some time for your questions. So if you have a question for our authors at any time during the talk tonight, click on the Q&A button at the bottom of the screen and we'll get through as many as time allows. In the chat, I'll be posting a link to purchase A Funny Thing Happened on the Way to Stockholm on harvard.com, as well as a link to donate in support of this series and our store. Your purchases and financial contributions make events like tonight's possible and help ensure the future of a landmark independent bookstore. So thank you. Thank you to our partners at Harvard University, and thank you to all of you for showing up and tuning in support of authors, publishers, indie book selling, and especially for science, because it really, really matters in this difficult time and always. And finally, as you may have experienced in virtual gatherings over this past year, technical issues may arise. So if they do, we'll do our best to resolve them as quickly as possible. Thank you for your patience and understanding. And now I am delighted to introduce the moderator for this evening's discussion. Thomas Michel received his PhD in biochemistry with Bob Lefkowitz in the 1980s and pursued clinical and research training at Brigham and Women's Hospital and Harvard Medical School, where he currently serves as a professor of medicine and biochemistry and as a clinical cardiologist. He is also an active teacher of clinical trainees, grad students, and MD PhD students, and leads a research lab studying cardiovascular signaling pathways involving nitric oxide and hydrogen peroxide. He notes that his closest ongoing encounters with the Nobel Prize revolve around his activities as the official accordion player for the Ig Nobel Prize ceremony held annually at Harvard. So without further ado, I'll turn things over to Thomas, who will introduce our authors and their work. The digital podium is yours, Thomas.
Thank you, Lauren, for that kind introduction. I really want to thank Harvard Bookstore, really one of the great independent bookstores of this country, if not the world. As Lauren mentioned, you can order Bob and Randy's book by clicking on the link in the chat. You'll be not only getting a great book, you'll be also supporting an endangered species in this country, the independent bookstore. And you can use the Q&A, of course, for questioning the authors. We'll be monitoring that and ask questions either as they arise or towards the end as time allows. And now, to introduce our authors. Bob Lefkowitz won the Nobel Prize in Chemistry in 2012 for his path-breaking work on G protein coupled receptors. These are the molecular receptors on the surface of cells that control virtually all functions of the body. For example, the very famous hormone adrenaline exerts its effects on cells through its actions on multiple receptors, principal among them the beta adrenergic receptor, which Bob has really devoted his life to studying as a paradigm. This is a very important receptor controlling heart rate, blood pressure, response to stress and fear, and many other responses as well. And drugs that bind to this receptor, beta adrenergic blocking drugs, are very important in the therapy of many disease states, most importantly, cardiac disease states such as hypertension and heart failure and angina. Bob's book describes his journey from growing up in New York City, attending the famous Bronx High School of Science, Columbia University for his undergraduate and medical degrees and initial clinical training, his days at the NIH for his introduction to research and his continued research and clinical training in Boston at Harvard, and then his initial foray into independent research, which he sustained for more than 5 decades at Duke University, where he developed his independent lab and made the discoveries that led to his Nobel Prize in 2012. Along the way, he has mentored countless students. I'm one of them, and research fellows. Randy is one of them, who have themselves gone on to careers in biomedicine. And his co-author is a distinguished professor in his own right, Randy Hall, who is a professor of pharmacology and chemical biology at Emory University. And he is co-author with Bob of A Funny Thing Happened on the Way to Stockholm. So Bob and Randy, welcome to the Harvard Bookstore. Bob, since both you and both Randy and I were mentored by you, I'd like to start by discussing mentoring. You know that biomedicine is filled with your former trainees, students, and postdoctoral fellows whom you've mentored when they were students or trainees. And indeed, one of your trainees, Brian Kobilka, was a co-winner with you of the Nobel Prize in Chemistry. What can you share about your secret sauce for being a successful mentor? What are your secrets for recruiting and training and launching the careers of young biomedical scientists? And Randy, what have you taken from your years of being mentored by Bob to your own approach to mentoring to your own students and research fellows? So Bob, please take it away.
Yes, thank you for that question, Tom. And I'm delighted to be here to talk with you about subjects of interest and about the book. I have a copy of the book in front of me. I'll hold it up. And we actually have in the book an entire chapter devoted to my 10 golden rules of mentoring. And I'm not going to give away all the secrets. I want you to be able to find something in the book that's new. But I will read you several of the 10 just to give you a flavor. The first is tailor mentoring to each individual's needs. I think this is very important. No two trainees are alike. And what works for one won't work for the other. Some, for example, are more gifted than others and can be challenged in ways that the less gifted cannot. The things that motivate one trainee are not the things which will motivate another. So I think learning how to tailor your mentoring to each individual's needs is very important. I'm always big on encouraging focus. I often tell people in the lab, there are 4 keys to success in research. The first is focus. The second is focus. The third is focus. And the fourth, you have to figure out for yourself. I often tell the story about focus that I view my role in the lab, one of the most important aspects of that, as maintaining focus. The young scientists seem to have a lot of trouble with that. And I would find often that if I go away for, say, a week, traveling, and I come back and I start talking to folks in the lab, I will often find that their focus has drifted. In a sense, it reminds me of the microscope that I used to use in medical school, which was old, bashed up microscope, which couldn't hold the focus. The stage would always slip. So in my room at Columbia Medical School in the dorm, when I would study at night, I would get the slide fixed in perfect focus. I'd look away at the atlas. When I came back, the stage had slipped. So I learned to put just enough pressure on the fine tuning knob to hold it in focus while I would look away, and then I could come back. And I realized that's sort of what I do in the lab. I keep just enough pressure on so that the focus stays on what's important. Enthusiasm, I have fan the flames of enthusiasm. Again, enthusiasm, actually the root of the word is a God within, which is in a sense what enthusiasm is, a flame burning inside. Enthusiasm, alas, is not something you can fake. And some people seem, I guess we probably all feel enthusiasm to a certain extent, but not everybody can express it as well, or is inclined to express it as well. At my 60th birthday, hard to believe 18 years ago, there was a 2-day Festschrift held in my honor at Duke. I think you were there, Thomas. And in any case, one session they had was a number of my former trainees, now all very prominent in their own regards, told stories, not just about their research, but about me and what it was like working in my lab. And I remember one of them, Rick Serione, who's now holds a named chair at Cornell University in Ithaca, told the story of how one of the things that just kept him pumped up while he was in my laboratory is that he knew for a fact that I believed that his project, which had to do with reconstituting receptors into lipid vesicles, that his project was, at least to me, his boss, the single most important project in the lab. And he believed that because I could kind of communicated that to him fairly directly. Well, then one day, he was talking with one of his lab mates, and he sort of mentioned that. And the guy said, well, I think you've got that wrong, Rick. Bob believes my project is by far the most exciting in the lab. Rick says, why do you say that? He says, well, because he's told me. So then they dragged in a couple of their mates, and it turned out everybody in the lab believed that their project was the most important one in the lab to me. And of course, the reason they believed that was I believed that, okay? I mean, there's no duplicity involved. It's just that in the moment I would talk to them, I would be quite convinced that what they were doing was the most exciting thing in the lab. I think that kind of enthusiasm for a trainee's work just has an empowering effect on a couple of other things.
And for me as a mentor, that has definitely been the number one lesson that I took away from having Bob as a mentor in the 1990s. That I think it's so important and crucial as a mentor to convey that enthusiasm to your mentees, because research is such a hard game, right? Research is like 90% failure. There's so many artifacts and technical problems and things that don't work for weeks and weeks or months and months. And it's so difficult to go through that as a trainee. But if you have a mentor who's just constantly in there and getting you pumped up on a daily basis, making you feel fired up, being your top cheerleader, like that, it just makes such a big difference. And so I try to remember how I felt during my downtimes at Duke in the 90s, and how Bob always bucked me up and really got me totally inspired. And I try to be that same kind of mentor for my students now. So to me, that was really a key aspect. And one of the parts I enjoyed in writing the book, most of talking with Bob about was his mentors at the NIH, because clearly his own mentoring style was informed by his mentors. So did you want to mention briefly your own mentors, Bob?
Yeah, so I had three scientific mentors in my career, two at the NIH. One was Jesse Roth, one was Ira Paston, both very distinguished scientists. Remarkably, both are quite active at this point in their careers, even though they're both in their late 80s, which is really something to aspire to. But I was particularly fortunate in that they had a completely divergent mentoring styles. Roth was, it was like he was injecting adrenaline. I mean, he was high as a kite. I would bring him any result and he would enthuse, etc. But to me, it was too much, okay? Because there were times I would bring him stuff that really wasn't all that good, but it didn't matter. He was over the moon. Then I would take the same finding to Ira Paston, my other mentor, and he would look at it. He was very critical. Unlike Roth's personality, he was very dour, didn't laugh very much. And he would look at the same findings and he'd say, you're excited about this? I'd say, yeah. And he'd say, and you said, Jesse's excited about this? I'd say, yeah. He says, well, did you do such and such a control? I'd say, no. Did you do this control? No. Did you do any control? Well, not really. He said, Bob, this is crap. You can't understand anything from this. And he'd send me back with my tail between my legs. So they had two very different styles. Jesse was very creative and very ebullient. He had an idea every 10 seconds, but he wasn't particularly critical. Now, Ira was just as creative, but he was extraordinarily critical and rigorous. And so I tried to take that blend of the two and mix them together. I tried to, I think, model Jesse's enthusiasm and creativity, but also to combine that with Ira's very rigorous and critical style. So I think for all of us, you know, there's no one ideal way to mentor, but I think that, you know what, I'm always happy to hear people like Randy, who trained with me, say that they've incorporated some of my mentoring style into their own. There's something, you know, we can talk about or not in the course of the hour is scientific lineages and why there might be scientific lineages. But let me mention just one or two more mentoring things, and then we can move on. One I'm not going to talk about is promote risk-taking. Obviously, the most important scientific problems often are the riskiest ones. And some are so risky that they're not even doable. And of course, learning how to be successful is finding the problems that are the furthest along the spectrum of risk without going over the cliff. That is to say, you actually can do that, as opposed to, working at one end where problems are trivial, but you can do them, or at the other far end where the problems are of overarching significance, but you have no chance of solving it. You got to find the furthest you can go on that spectrum. So I always encourage risk-taking and working on important projects. But I think there's probably nothing more important than one I wrote here, empower trainees. This is a very fine balancing act, because I mentioned before that you have to mentor each trainee differently. So you really have to be a psychologist and get to know the person that you're dealing with. But you can err in two ways here. Some mentors tend to micromanage. Okay, they're telling every day, they want to tell the trainee exactly what to do, so that the trainee is, in essence, working as a glorified technician. On the other hand, you have people who are so distant as mentors that effectively they don't give anything to the trainee. They're basically on their own and training themselves. So you need to find that right balance. Now, what I have found empowers a trainee the most, my own style, and there's no one ideal, is in general to hang back and work by suasion rather than barking crisp orders, and to the extent that the person has the ability, to let them develop the problem with me just doing the coaching. Because if you don't do that, if you micromanage them, when you ultimately meet with success, they lack the sense of intellectual ownership of the success that gives them the confidence to be able to do it again when they're on their own. So if, on the other hand, you've given them enough room so that they can feel that, hey, when it works, hey, I really did this. Not Bob did this, that was all his idea, but I really did this. That gives them the confidence to really be able to do it again. Now, as I say, on the other end of the spectrum, if you don't mentor them at all, if you just leave them on their own, they may have the confidence, but then you haven't given them anything. So there's that. And just, well, so others emphasize storytelling. We can talk about that some other time. Laugh and have fun. Well, this is just a matter of personal style. I mean, there's no one right way to do science. We all have different personalities. People often ask me, if you hadn't been a scientist and a physician, what might you have aspired to? And I never hesitate. I mean, I would have liked to have been a stand-up comic, no doubt about it. And in my, this is a true thing, and in my lab meetings, anybody who's been there know there's a lot of laughing that goes on. Not that I tell jokes, but I have an offbeat perspective, and I'll often put things together in a way that elicits laughter. And I find that when people are laughing and having fun, they are at their most creative. Now, why that should be so, I'm not sure, but when you think about it, humor is basically a creative endeavor. In the moment that you see a joke, you make a little discovery, okay? And I mean, there are times when I'll say something that I think is funny, and immediately 2 or 3 people will laugh. And then after a latency of maybe 300 milliseconds, another few will laugh. And then another few. In other words, people are making the discovery, are seeing the joke, which is usually the juxtaposition of several things which seem initially incongruous, but when you think about it, hey, they have an interesting relationship there. Well, there are a lot of elements in that of the discovery process. So I have found in my lab meetings that the more I get people laughing and seeing relationships that are perhaps not immediately clear, the more the creativity seems to flow. And then you get into this flow where people are just, giving forth ideas. So I think the idea of having fun does, lead to creativity. And then, of course, there's just the idea that I think people do their best when they're having fun. I mean, if you talk to a basketball team after they've just lost a big game and they really played way below their level, if you ask them, well, what was wrong out there tonight? They'll often say, we just weren't having fun. But when they're having fun and all loosey-goosey, then everything seems to work. So for me, having fun and teaching people that having fun promotes the quality of the work is, I think, also an important part of mentoring.
Bob, thank you for mentioning basketball, because it leads into my next question. One of my colleagues at the Brigham, Raj Gupta, told me in looking up your book that your book, very successful, even though it hasn't been published yet. It is currently ranked #1 on Amazon for basketball biographies.
Yes, I'm very proud of that.
Ahead of Kobe Bryant, ahead of Kevin Garnett, and Mike Krzyzewski wrote a complimentary blurb about your book, and it's actually placed #1 ahead of several Nobel laureates.
Yes.
So I want to ask you, what can you tell us about Duke basketball that resonates with you?
Okay, so first of all, let me say that there are many things in common between being a basketball coach and being a mentor to scientists. And I think if you think about some of the things I've just been talking about in terms of mentoring, whether it be empowering, focus, these kinds of enthusiasm, I think you can sort of see that. But let me tell you some things about Coach K. So I've been a career-long fan of the Duke basketball team. When I moved to Duke in 1973, I became involved. In '76, I purchased season's tickets, which I have to this day. And in fact, it was at a Duke basketball game a few years ago when Randy came up to visit that over dinner, he pitched me the idea of doing this book, which I had been thinking about for years, but I think I know I never would have done if it wasn't for Randy working with me on it. Anyway, but I never knew Coach K, even having followed the team all those years. I admired him, but we had never had any personal interactions. Then on October 10th of 2012, I received a call from Stockholm telling me that I had won the Nobel Prize, which, to my surprise, I learned was the very first Nobel Prize ever awarded to a faculty member at Duke University. Well, it got a lot of press, and 2 days later, Coach K himself calls me up, and he says, Bob, after very nice schmooze, which went on for probably 15 or 20 minutes, he says, Bob, look, I feel a real kinship with you because, he says, as you know, I brought Duke our very first NCAA basketball championship, and now you've brought us our very first Nobel Prize. So I'd like to bring you down to Cameron Indoor Stadium to honor you. I said, well, what do you have in mind? He says, well, why don't we leave it a surprise and you'll see when you get there. So about a week or two later, I went down there, mid-October, which is this countdown. What is it, Randy? Countdown to Madness?
Countdown to Craziness.
Countdown to Craziness, which commemorates the very first official practice of the team, and sort of denotes the opening of the season. So I went down after they introduced the team. Then Coach K called me to center court at Cameron, which has a big K in the middle of it, the Coach K court. And together with these towering trees, I was basically looking at everybody's waist and hips. I've never felt so short in my life, even though I'm 6 feet tall. They presented me with my very own personalized jersey. My name, Lefkowitz, spelled correctly, which is a nice thing when your name is Lefkowitz, and the number 1. And then they all walked away, and I started to leave the center court. And of course, everybody's screaming and yelling. And for those of you who've never been in Cameron, it's a small arena, only about 9,000 seats. And the students occupy all the seats closest to the court. They're screaming and yelling. And the coach, he motions to me to stand back and just receive the adulation of the crowd. So I'm standing there, and the noise is deafening. And then I realized that the students in unison are chanting something. And they're pointing at me, and they're chanting, and I can't quite hear it. And the Duke students are famous for chanting things in unison, typically at opposing players, and typically when they have fouled out of the game. Anyway, finally it comes into focus. They're pointing at me, and in unison they are chanting, "He's so smart. He's so smart." And wow, so at that point I put my arms up in the air, and I just sort of, took it all in. Well, okay, that would have been the end of the story. But 3 years later, 2015, the team wins their 5th national championship under the coach. And of course, President Obama, a diehard college basketball fan and one who loves Duke, invites the team and the coach and the university president up there. A couple of days later, a picture appears in the Duke Chronicle, the student newspaper, showing Coach K presenting Obama with his own personalized jersey. That's fine, it says Obama, but the number 1. Now, wait a minute. Immediately I'm offended. This is my number. Now, there's a long tradition at Duke that when a really outstanding player leaves to go on to the pros or wherever, they retire his jersey, just as many schools do. And what they do is they make a huge image of it with the number, and they hang it from the rafters at Cameron Indoor Stadium. So as soon as I had received my jersey 3 years before, I hung it from the rafters in my office. So I never wear it, but in fact, it hangs right in my office, directly next to the Nobel Prize, I would say. So I have my 2 most prized professional accomplishments there. So I was appalled when I saw that they were trying to assign the president my number. So by this time, we had become good friends, done a number of things together. He has a leadership academy that I participate in programs. So I immediately shot off an email to him. I said, "Coach, I was so thrilled, with the championship, and that you were invited to see President Obama, as I had the pleasure of meeting him as well once before. But I couldn't believe that you were giving him my number." Now, I said, "You may not know this, but my number's been retired." And I included a photograph of it hanging from the ceiling in my office next to the Nobel Prize. I said, "So what's the story on that?" Within an hour, I have a message back from him saying, "Bob, look, you have to understand, I didn't want to do it." He says, "But it is the president of the United States. What was I going to do?" He says, but he says, "Look, you know, and I know, you're the real number 1. Well, I mean, what are you going to say about it? I wrote back, I said, "Coach, all is forgiven, and it'll be fine." So that's how the jersey story sort of ended.
And
Wonderful,
Thomas,
wonderful. Yes, please.
Thomas, in terms of your question about why we're ranked number one on Amazon in basketball biographies, we have wondered the same question, because obviously there is some basketball in the book, as Bob was just telling one of the stories, but it's not primarily a basketball biography.
Well, that's great.
What we've discerned is that probably the Amazon algorithm figured out that Bob is from Duke, and most people who come from Duke are mainly basketball players or basketball coaches in terms of having books. And so I think Amazon just assumes that anyone from Duke, it probably has to do with basketball. And so somehow we are ranked in the basketball biography category. So
another reason not to buy from Amazon. Let's now get back to your book. Sorry, I probably shouldn't have said that, but that's probably the least offensive thing I'm going to say. Randy, you had something?
But we do want folks to support the Harvard Bookstore. So certainly, if you're going to buy the book, go out and buy it from Harvard Bookstore, one of the all-time great indie bookstores.
Absolutely, or your local independent bookstore, a threatened species for sure. I'd like to get back to your path, maybe dial back a few years, Bob, and with Randy, your comments as well. The subtitle, or the post-colonic phrase in your title, you always taught us that you'd have a title of a research paper with a pre-colonic phrase that was shorter and pithy, and the post-colonic phrase that might be explanatory. And I see that you carry that forward into your book. Good on you. Or Randy, I should say. And you call yourself an accidental scientist. Yes. And if you could just tell us a little bit about the origin of that term and how you made that pivot from thinking that you were going to be the best doctor in the world and becoming the best scientist in the world?
Okay, that's a wonderful question. So sometimes when I speak to student groups about my career, I title the talk "A Tale of Two Callings." And of course, what I refer to by a calling is normally we associate the term calling with clergy, but you can feel a calling to almost any field of endeavor. It's simply a deep-seated sense at an intuitive level that you are destined to do a certain thing. Of course, I couldn't really conceptualize it in that way, but as I look back over my life, I felt a calling to the practice of medicine when I was 7 or 8 years old. My inspiration was my family physician, a man named Dr. Joseph Feibusch, who was an internist and general practitioner. He practiced in the Bronx where we lived, and he made house calls. And I was thoroughly taken with him. This guy knew all kinds of special stuff that the rest of us didn't know, sort of like the clergy know special stuff. And then he could use this special knowledge to heal you. He let me play with his stethoscope to the extent that I could understand it. He would kind of explain to me what he was doing. And I just absolutely fell in love with the idea of being a physician. And so I decided by age 7 or 8 that that's what I was going to do with my life. And it was a very clarifying vision because I never had to worry along the way as to what I was going to do. So I went on to a specialized high school in the Bronx called the Bronx High School of Science, an absolutely remarkable school. It's a public high school for gifted and talented. Admission is by a competitive examination. That's the only criterion. And I am the 8th Nobel laureate to graduate from that high school. To put that in context, consider this. If the Bronx High School of Science were a country and not a high school, it would rank something like 20th in the world for most Nobel Prizes. No, there are only about 19 or 20 countries that have more Nobel laureates than this one high school. From there, I went on to Columbia College and Columbia Medical School, heading straight for my career as a practicing physician. In fact, even though I loved science, was a chemistry major, not once in high school, college, or medical school did I ever do any independent research. Whenever I had in medical school elective periods, I'd always do clinical electives because I wanted to be top of my game when it came to clinical medicine. But I graduated medical school in 1966, kind of the height of the Vietnam War. And there was a lottery draft at that time. That meant if you were a male over 18, you would be assigned a number, and then they would pick numbers out of a barrel, and depending on whether your number came up, you'd be drafted or not and serve in Vietnam. Not so for physicians. For physicians, there was no lottery. You were drafted. You got 1 or 2 year deferment after medical school, and then you went in, Army, Navy, Air Force, whatever. You served 2 years, and almost without fail, one of those 2 in Vietnam. Well, it was an amazingly unpopular war. It was felt by many of us to be immoral, possibly illegal, and we didn't want to support it. But there were very few legal ways around being drafted into one of the services in Vietnam. One of the very few was to be drafted into the United States Public Health Service. And why was that desirable? Because they had a number of positions, billets they were called, in stateside research institutions like the NIH, the CDC, and other such research installations. But as you can imagine, the competition to be accepted into that service was extraordinary. So they got the best of the best of the best. Almost everybody who succeeded in getting into the public health service in those days, was like first or second in their medical school career class, etc. So I was successful because I had high academic standing. I was drafted into the public health service and assigned to the NIH. And it was there that I began doing research, not because I wanted to do research. It was interrupting my prized clinical training, but because it was the best way to avoid supporting the Vietnam War. It was quite clear that I had no talent for it whatsoever. Over the first 12 to 18 months, I failed in a way that I had never failed before in my life. I learned a lot about failure and how to counsel young people about failing in research, which, as we all know, is the main thing you do. But finally, toward the end of it, things started to work, and I got my first papers and my very first taste of what it meant to write a paper, make a little discovery, etc. So I was starting to like it a little bit, but it certainly was not my intention to make a career out of it in any way. So at the end of the 2 years, despite the importuning of my mentors that, hey, you're really onto something with your project, Bob, why don't you stay a couple of years more and really build a career on this? I said, well, it is nice, but I really need to get back to clinical medicine. So I went up to the Massachusetts General Hospital in Boston to begin a 3-year program. One as a senior resident in medicine, and the other 2 years of cardiology. So I threw myself into the clinical work, which I had always loved. And to be honest with you, I was pretty good at it, and I really enjoyed it. The first 6 months, it was just very intense clinical work, 12 hours on, 12 hours off. It was brutal. But I did really enjoy it. But here's where I had the epiphany. I realized during that time away from research that I really missed, something was missing. Something was missing. I was not content as I would have hoped to be, and as I had been doing pure clinical medicine in the past. And so it was at the end of those 6 months that I realized somehow I need to incorporate research into my career plan. And so I sought out a mentor, Edgar Haber, who was the chief of cardiology at the Mass General and also a very noted immunochemist. And he agreed to take me into his lab for as long as I wanted. And so there, while continuing my clinical studies, I first began my studies of adrenergic receptors. I made some headway, but it was hardly brilliant. And in 1973, I moved to Duke because I had given several papers at the American Heart Association, and the chief of cardiology at Duke had heard those. He was looking for somebody to start a new program in a frontier area that was being called molecular cardiology. You may be familiar with that, Thomas, as one of the great practitioners of the art. And so I went to Duke to have a dual career as a physician, an internist, and a cardiologist on the one hand, and to open up my laboratory to see what would happen. I would say for the first year or two, I spent about 40% of my time doing clinical work, rounding in cardiology and medicine, doing clinics with the trainees, and maybe 60% in the laboratory. But then over the first 3 to 5 years, that changed dramatically because we started making one advance after another. I became totally obsessed with the projects that we were working on. And I began spending more and more time in the laboratory. And so I would say that by the time I reached 5 years after coming to Duke, I was probably spending 85 to 90% of my time in the lab and maybe 10 to 20% in the clinics. The interesting thing is, I never made a conscious decision to do that. It just happened, okay? What was going on was that this calling to do research was just overtaking everything. In spare moments, driving home, hiking in the woods, in the shower, what I'd be thinking about is, how the hell am I going to purify that protein? Not, that was an interesting murmur that I heard in clinic today. Could that really have been X, Y, or Z? So it was really just sort of taking over my being. And then, as they say, the rest is history. So were it not for the Vietnam War and being drafted and being sent to the NIH, I never would have tried research. And I think I would have happily practiced medicine and cardiology my entire career. I cannot imagine I would have been anywhere near as fulfilled as having been able to have one foot in each world all these many years.
Bob, thank you very much. We're the hour is moving along. There's a question I'd like to ask you that is rooted in part in a statement you made both in the book and also just now about your moral opposition to the Vietnam War. We are looking at the end of a national leadership period in which science was denied, and we're entering a leadership period in which science is much more effectively supported. We're looking at Eric Lander now as the science advisor to the president, raised to cabinet level. So my question for you, and I know that you have signed petitions in support of a variety of political causes, including our now president, Joseph Biden. What can scientists do? What should scientists do to ensure that science remains at the forefront of policy? How can we communicate what we do and why we do it? How can we get involved in a way that's meaningful while still pursuing this career, which is more than full-time?
I guess this all has to do with communication and having opportunities to communicate. One of my heroes, and in general, when we talk about heroes, we're usually talking about people who are from a generation before us. But a number of my heroes are contemporaries or peers. So when I was at the NIH, 1968 to 70, I was part of a remarkable class. Consider that there were only 50 to 75 of us each year who went in there. In my class, all physicians, none of us with any significant prior research training, were the following: Michael Brown, Joe Goldstein, Harold Varmus, and myself, 4 future Nobel laureates, and one other individual I want to focus on. He didn't win a Nobel Prize, but you may have heard of him, Tony Fauci. Tony was one of my good friends from that era and forward. And in the book, I tell some stories about Tony and experiences that Tony and I had. Tony is, amongst other things, and he's one of my heroes, but Tony is the quintessential physician scientist, okay? And his communication skills are, about at the highest possible level. It would be great if those of us who are physician scientists, or just scientists, were able to have the kind of platform that Tony has. We don't. But there are other ways that we can get out there. One is, I've always been, how can I put it, uncharacteristically shy, let us say, about talking about my scientific work to reporters or in any public way. This stemmed from several experiences I had, which are described in the book, where I did talk to reporters, and they got the story so damn bollocksed up that it was a source of embarrassment to me. But if we can get our stories out there so that people understand what we are doing and how important it is, I think this is a perfect moment for that, because we've just come out of a dark 4-year period where science was denigrated. I have to tell you that this is not unique to Trump. He brought it to an art form, the denigration of science, but it was going on for years before that by the Republican Party. And in fact, in my what's called banquet speech in 2012, which is included in the book, I spoke specifically about the denigration of science by what I said in my remarks, which you can read on the Nobel website, was that one of our political parties in the United States completely denigrates, I use other wording, denigrates science. I never mentioned the Republicans. I thought it would be too controversial. And anyway, as I was stepping down from the podium, there was an announcer, and this is all on the Nobel website if you want to hear, who is sort of doing play-by-play, much like somebody at a golf tournament. It was Dr. Robert Lefkowitz just giving his remarks at the Nobel banquet, in which he completely trashed the Republican Party for the way they treat science. I had never mentioned the word Republican. My text is there, but obviously they knew what I was talking about. Amongst the many traditions, less important, that President Trump bashed was, it's been a long-standing tradition for the President of the United States to meet in the Oval Office with all American Nobel laureates on their way to Stockholm to receive their medals. And that's gone on for a long, long time. I had the pleasure and the privilege of meeting together with 4 other American Nobelists in my year with President Obama. We've got some really fun stories about that in the book. But Trump never met with a single laureate. The very first year, he said, "I'm not doing this." Never said why. Immediately, several of the laureates said that had he invited them, they wouldn't have gone. And that was the end of that relationship. So he never met with a single laureate. So I think, yes, it would be wonderful. We've got to get the word out there. And we could write op-eds. I've written several op-eds in the last couple of years about the importance of physician scientists. And if we want to know about the importance of that particular breed, just look at Tony Fauci. And it's a declining and a very small group who opt to become physician scientists. Currently, only between 1% and 2% of all physicians indicate that they do any sort of research, any kind of research, as part of their career, be it clinical or basic or whatever. So we have to train more physician scientists. That's something I'm particularly passionate about. And I am the founding president of a nonprofit called the Physician Scientist Support Foundation that is trying to get the word out. But again, I think there's no better advertisement for this whole enterprise than somebody like Tony Fauci. And I think we have to ask ourselves as a society, where is the next Tony Fauci coming from? You know, are we training the next generation of epidemiologists and public health physicians? So I think this question brings out just a very, very important issue.
Bob, thanks for your response. Randy, you're a few blocks away from the CDC. You're in a state that has seen its share of, shall we say, political excitement. If you could perhaps comment in the same vein, and then I think we're going to need to go and we'll want to go to some of the questions that have been piling up in our Q&A. Randy, the floor is yours for a minute.
Yeah, absolutely. So I would just say that this is one of the reasons why we wrote this book. You know, Bob and I believe that public outreach about science is so important. The more the public understands that scientists are humans and real people, we're not just robots that generate data and make discoveries, but we're real, you know, humans and have interesting and fascinating lives. That gets the public to connect about science. I think it's very difficult to write a book that's just purely about science, right, and data and describing discoveries. Putting it in the context of a memoir like this, I think is more palatable and more enjoyable for a lot of lay people to read, because it's just fascinating to hear about someone's life, especially someone's life like Bob Lefkowitz, who's had an amazing and fascinating life, and he's a great raconteur, a great storyteller. And so it's just, I think the book is very readable, but also you can put some science in there and get the message across to the public in a very enjoyable way.
I just say one little coda to that, Thomas, which is that I think that one of the things that we wanted to do in the book, and I hope we've succeeded, is just what Randy says, make it clear that scientists are humans. They have the same passions, the same strengths, the same weaknesses as everybody else. And we tell some, I think, interesting stories about just how emotional science can be. I mean, science is a very competitive game. And when there are big discoveries to be made, there is often intense competition. I think probably the classic example of that is Watson and Crick's discovery of the double helical structure of DNA, presented in Watson's famous book, Double Helix. And there are other examples, many other examples. And along the way in my field, there were several very intense collaborations we were involved in with tremendous emotional pressure. And we tell those stories, which I think, regardless of whether you know or care anything about science, you will find very interesting.
I'd like to tap into emotions as my last couple of questions before going to our list of Q&A that are piling up now. And that is to tap into the emotions that you describe about discovery. Bob, just very briefly, and then Randy, what discovery did you make that at the moment seemed like the most exciting thing you've ever done? And even reflecting on it now, it senses or it recalls to you the sense of I've just found out something that's really, really cool and potentially important. It's probably difficult for you to separate out.
It is difficult. It is difficult. It's sort of like asking me which of my 5 children is my favorite. So, but all that said, probably the one that I would choose, and believe me, there are a bunch that are right up there with it or just behind it, would of course be the when we cloned the gene in cDNA for the beta adrenergic receptor. So we had been on a long journey by that point, somewhere around 15 or 18 years, in which we had steadily built this edifice, starting with developing all the techniques which were necessary for even showing there was such a thing as a receptor, studying it, purifying it. And now we were finally going to find out what its amino acid sequence was going to look like. It was very difficult and very competitive, as we describe in the book. If you had asked us in advance, what do you think it'll look like? And in fact, people did ask me, what do you think it's going to look like? I said, I think it's going to look like nothing, because I think it's going to be the first one of its kind, the first G protein coupled receptor that we're going to find the structure of. I think that, it'll be a totally novel gene family. Well, okay, so finally we succeed. And, the databases were pretty meager in 1986. We get the sequence, we look at it, and oh my God, it only looks like one other protein, rhodopsin. And it looks a lot like rhodopsin. Now, for those who don't know what rhodopsin is, it's protein used to be called visual purple. It's in the retina. It's what allows us to see light. It's essentially a receptor for photons of light. And it was known that it worked through a G protein. Still, nobody ever dreamed that there would be a structural relationship between the beta receptor and rhodopsin. They both had the same architecture, which was a structure where there are 7 hydrophobic domains. The protein weaves back and forth across the plasma membrane 7 times. And in addition to that, a number of the amino acids, not many, in analogous positions were identical. So it's quite clear they were the 2 founding members of a new gene family. Well, as soon as we saw that, it was already known that histamine, serotonin, dopamine, on and on, many different hormones and drugs seem to work through G protein coupled receptors. And so right in that very first paper in Nature in 1986, we hypothesized that the whole family of GPCRs would look like this. Over the next couple of years, my lab cloned another 8 or 10 additional GPCRs, mostly adrenaline receptors, but a serotonin receptor. They all looked exactly like that, confirming that this was a new gene family. Today, we know that there are 1,000 different members of this gene family. They mediate the effects not only of countless hormones and drugs, but our sense of taste, our sense of smell, our visual processes, and many, many other things. In fact, today, anywhere from 30 to 50% of all FDA-approved drugs target this gene family. So it's been of enormous importance. But it was in that moment when we went to the databases and we saw it's rhodopsin, that was a eureka moment, because we didn't see
that's when you saw the light.
Yes,
Randy, briefly.
Well, Thomas, we're a little short on time.
Yeah.
We have about 5 minutes, and Lauren, I think, is getting pretty strict about our time. So I kind of would like to get to a couple questions from the Q&A.
By all means. Listen, thank you all for responding to these interesting these pathways that have been described, and I want to thank our various questioners. Randy, I'll let you drive here. Well,
I was interested by the question from Taylor Covington. Want to know what advice that Bob has for young scientists who are looking to launch their careers.
Wow, that's a really open-ended question. So the first thing you've got to decide is what sort of career do you want to have? The key decision, I'm going to suggest that I'm going to not tailor my comments at all to physician scientists, okay? Because if you're a physician scientist, you're going to be associated with a major academic medical center or some medical center, et cetera. But let's talk about PhD scientists who have just finished a PhD and say maybe a postdoc in some field, biochemistry, genetics, whatever. You have several different paths that you can go down, and you need to make a decision initially as to what you want to do. You can be an academic, like the 3 of us here having this discussion, become a professor, run your own lab. You could follow a career in biotech or pharma, which are related, but still somewhat different. Or you could have a very different kind of career where maybe you want to do research, but you love teaching, or you could work in a research institute, obviously. Or maybe you like teaching a lot, but you don't want to totally give up research. You might do better in a small liberal arts college, say in the biology department, running a small lab program with maybe some support from the school and having undergrads that you teach. Now, each of these career paths have distinct advantages and disadvantages. And with each of my fellows and students, there comes a time when we have the talk. Of course, with my kids, that was about the birds and the bees. But with the students and fellows, it's about what am I going to do with the rest of my life? And I go through with them, what the advantages and disadvantages of those different career paths are. I have found that for most of my fellows, by the time they're coming to the end of their time with me, I have a pretty good sense in my mind as to what I think they should do, given everything I know about them, their proclivities, their personalities, their strengths, their weaknesses, etc. But I never reveal that initially. I always say to them, what do you think? And most of the time, they will say, okay, I want to do this or that. What do you think, boss? And as far as I'm concerned, I would say with 90% agreement, I agree with them. I mean, it's very, very rare for me to have reached a different conclusion independently. Now, there are some people, and they're a minority, but a significant minority, who really could do fine in both contexts, okay? So there you have a little more flexibility. But I think that's the very first decision you have to make. And I don't think we have time for me to go into the strengths, the advantages and disadvantages of the careers. I mean, when before the pandemic, used to, go here and there as a visiting professor. And, you guys have both done that drill. And there's always a time during your visiting professorship where you have lunch with the students and fellows. Question always comes up. And there, with a fuller allotment of time, I go through in some detail what I see as the advantages and disadvantages of the different types of careers and what sort of personality and life goals, would lead you down one path or the other.
And so, Bob, since you didn't specifically address physician scientists in that answer, we did have a couple questions specifically about physician scientists. For example, Santiago Lamas asks, and I know that this is a question near and dear to your heart, so I definitely wanted to raise it. Santiago asks, is the physician scientist model, still a pillar of biomedicine in the modern day when such a profound level of specialization is needed? So do we still need physician scientists, or is it passé?
Yeah, it's an excellent question. I happen to deeply believe we need physician scientists. I really believe that physician scientists, even when they do very basic research, such as I have done throughout my career, bring a unique perspective to the research enterprise. And as we've seen with GPCRs, even though I never set out to cure a disease, develop a drug or a treatment or whatever, I mean, the work that we did over a number of decades now underpins 700 drugs and the development of drugs. So I think that physicians, scientists tend to gravitate to problems which, even if they are on the basic end of the spectrum, that they can intuit might have some very important clinical and therapeutic implications. So I think that physician scientists have a real role to play. I will say that I do regret the extent to which all of medicine has become super specialized, and in my view, over specialized. It was very, very different in my day. Now, no disrespect to any orthopedic surgeons on the phone, but okay, I'm sure there are some, and I don't mean to offend, but I was at a medical school reunion about 5 or 10 years ago and encountered a very good friend of mine. He'll remain nameless, a wonderful guy. And he had spent his career as an orthopedic surgeon. He was already retired. And he had also actually been the team physician for a very prominent professional sports team. I won't tell you which sport it was because I don't want to give away his identity. Anyway, we got to talking, and he told me about his career and this and that. About a year later, my son, who lives in the same city as him, had a hairline fracture in one of the bones in his ankle. So I called up my friend and I said, would you be willing to see my son, Josh? And he said, well, what's the problem? So I explained it. He says, well, I'll have one of my associates see him. I don't do ankles. I said, you don't do ankles? Why don't you do ankles? He says, well, we tend to specialize. I said, well, what do you do? He says, I do shoulders. I said, only shoulders? He said, yeah. I said, right or left? Well, I don't think he thought it was all that funny. But anyway, there's a lot of specialization I think there's too much specialization. But anyway, that's the way I see it.
Well, I want you to know, Bob, that the question that was posed, which Randy selected out of multiple questions that remain open, is from my very first postdoctoral fellow, my very first own trainee, Santiago Lamas.
Fantastic.
You're talking to your grandson right there.
Scientific grandchild. I love it.
There we go.
Santiago, delighted to meet you. You had a terrific mentor.
As did he. All right. I think that we're probably on our way towards the conclusion. And I think at this point, we're supposed to be turning it over to Lauren, who will thank us. But before I turn it over to her, I want to thank Bob and Randy for sharing their insights, for writing such a great book. I can't wait to read it in its entirety. I look forward to visiting you both and getting a personal signature on it. And I want to thank Harvard Bookstore for bringing us together and for all that they do, and to all of our attendees and their very thoughtful queries. And I hope they take away from this the sense of inspiration, of scientific excitement that Bob always solicits. And I think that's come across. And both Randy and I were talking about how when we were reading the book, and certainly this is much closer for Randy than myself, we can hear Bob in our mind's ear, telling us these stories, and they only improve in the retelling. All right.
Thank you, Thomas, very much. And thank you for your masterful emceeing of this entire hour. It was just great.
Thank you all. Thank you so much, Bob, Randy, and Thomas, for this fantastic conversation. And thanks to all of you out there for spending your evening with us. Please learn more about this fascinating book and purchase A Funny Thing Happened on the Way to Stockholm at harvard.com. And on behalf of Harvard Bookstore, the Harvard Division of Science, and the Harvard Library, all here in Cambridge, Massachusetts, have a good night, keep reading, and stay warm. Thanks, guys.
Bye. Bye-bye.